Good day. So today we are to discuss the Moivre's theorem and its application on complex numbers. So for example, we have this complex number z is equal to a plus bi in rectangular form, and we raise this complex number to n, and n, let's say, is a positive integer. So we have, let's say, z raised to n is now equal to a plus bi raised to n. So it will be very inconvenient if we are to expand this one, especially if we have n is a high value. So we are applying the Moivre's theorem. We have z raised to n, but first we need to convert this complex number from rectangular form to the polar form. So what is the polar form? That is the modulus multiplied by the quantity cosine of theta plus I, the sine of theta, this value raised to n. If we are to apply the Moivre's theorem, this is the same as z raised to n is now equal to, we have r, we raise it to n, then I multiplied by the quantity, we have cosine. So we have to multiply this n to the angles or to the argument. This is n times theta plus I, this is sine of n times theta. So this will be our equation. Okay, so let's have an example. Okay, so let's have, what will be the equivalent of 1 plus I raised to 4. So first, we need to convert this complex number into polar form. So from rectangular to polar form. So this is, this one lies on the first quadrant. Let's say this is the value of b is equal to 1 and the value of a is also equal to 1. We also need the argument. So we have, this is the tangent of theta is equal to 1 is to 1. 1 is to 1, that angle is 45 degrees. That will be the argument. So we also need the modulus. So we have the modulus equal to r, that's the square root of a squared plus the b squared. We have the value of r is the square root of 1 squared plus 1 squared. So we have the modulus is the square root of 2. So if we are to convert this one, the 1 plus I to polar form, we have 1 plus I raised to 4. That is the same as in polar form. That is r multiplied by the quantity cosine of theta plus I sine of theta. This is, I raise it also to, I raise this one to 4. So we have, this is equal to, what is our modulus? That is the square root of 2. I multiplied by the quantity, we have cosine of the argument, that is 45 degrees. We have cosine of 45 degrees plus I sine of 45 degrees. This value raised to, I raised to 4. So applying the Moivre's theorem, we have, this is the square root of 2. I raise that to r raised to n. We raise this one to 4. Multiplied by the quantity, this is cosine. We multiply this exponent to the angle. This is now cosine 4 multiplied by 45 degrees plus, we have I sine of 4 multiplied by 45 degrees. And then we simplify. As we have now the equivalent of 1 plus I raised to 4 is equal to square root 2 raised to 4. That is the same as 2 raised to 1 half I raised to 4. This is multiplied by cosine. We have cosine of 4 times 45 degrees is 180 degrees plus I sine of 180 degrees. So what is 2 raised to 1 half multiplied by 4? This is the same as 2 raised to 2 or 2 squared multiplied by cosine 180 is negative 1 plus I sine 180 is 0. So we'll be having the equivalent of 1 plus I raised to 4 is 2 squared is 4 times negative 1. This is negative 4, then 0. So this will be our answer. It is equal to negative, that's negative 4. So let us discuss the roots of a complex number. So for example, we have z raised to 1 over n. It is equal to a plus bi raised to 1 over n. So again, it is more convenient to determine the root of a complex number in polar form. So what is the polar form? This is we have r multiplied by the cosine of theta. Or the quantity, let's say, cosine of theta plus I by the sine of theta. This is raised to 1 over n. If we are to simplify this one, 0 raised to 1 over n is equal to the modulus. This is raised to 1 over n multiplied by the quantity cosine of this time. Your theta will be added with 360 degrees multiplied by k. This is divided by n. Then plus I sine of your angle or the argument theta plus 360 degrees multiplied by k. This is divided by n. So we're in the value of k is simply equal to 0, 1 up to n minus 1. So since if you see nth root, for example square root, we are expecting 2 roots. So, if, for example, we are to compute 2 roots, we are to use 0 and 1. Cube root, we have 3 roots. So, we are to use 0, 1, and 3, and so on. So, let's have an example. For example, we have for example, we are to determine the cube root of 8. Cube root. So what is the cube root of 8? So we may directly answer that the cube root of 8 is positive 2. That is the real root. So since cube root, we are expecting 3 roots. So we are to look for the other 2. So if we have 2 as the real root, we may have 2 another imaginary root. So how do we express 8 into a complex number? So this is a pure real number. You have z equal to 8 plus 0 I. You don't have an imaginary part. So if we are to plot this one, we have the value of a is equal to positive 8 and the value of b is 0. So therefore, what is the argument if we have a pure real part complex number? So the argument theta is automatically equal to 0. And what is the equivalent of its modulus? R is equal to the square root of a squared plus b squared. But again, for this case, a is equal to a, b is equal to 0, r is equal to the square root of 8 squared plus 0 squared. So basically r is the same as 8. So if we are to convert this one, we have z is equal to 8 plus 0i, or we may neglect this one into polar form r cosine of theta plus I sine of theta. We have this as 8 divided by cosine 0 plus I sine of 0 degree. So this is the equivalent polar form of this complex number having a 0 imaginary part. So what if we are now to raise that to 1 over 3 to determine the cube root? Okay, so we have that. We have z raised to 1 over 3. This is equal to, we have 8. This is multiplied by the cosine of 0 degree plus I sine of 0 degree. This this is now raised to 1 over 3, the cube root. So if we are to simplify, this is the same as 8 raised to 1 over 3, then multiplied by cosine, our argument, that is 0 plus 360 degrees multiplied by k divided by, okay, what is our n? That is 3 divided by 3, okay, plus I sine of 0 degree plus 360 degrees multiplied by k divided by, this is divided by 3. So this is the equivalent of 8 cosine theta, cosine 0 degree plus I sine 0 degree. Okay, this quantity raised to 1/3. So we are now to use the value of k equal to 0 and up to 1 and 2. Since we are expecting 3 roots, since that is a cube root. So for example, we are to use if, let's say, k is equal to determine the first root. So let's say if the value of k is equal to 0, we have that as 8 raised to 1 over 3. This is multiplied by cosine of, what is our argument? 0 plus 360 degrees multiplied by 0. This is divided by 3. A plus I, this is the sine of 0 plus 360 degrees multiplied by 0. And this is divided by 3. So this will be the first root. Alright, so let's have it as the first root. And that's good. So this is basically cosine of 0. What is cosine of 0? Cosine of 0 is positive 1. Okay, sine of 0 is 0. So cube root of 8, that is the positive 2. That is our first root. So to determine the second root, so we have if k now is equal to 1, we have the second root is equal to 8 raised to 1 over 3. This is multiplied by cosine of 0 plus 360 degrees multiplied by 3. This is divided by 3 plus we have I. This is sine multiplied by 0 plus 360 degrees multiplied by 1. This is divided by 3. Okay, so let us determine the this is multiplied by 1 since k is equal to 1. So what is cosine of 0 plus 360 times 1 over 3? 360 times 1 divided by 3, that is 120. What is that value? So if you have to use our calculator for this one, so that will be the same as cosine 360 divided by 3. That is negative 1/2. Then cube root of 8 is positive 2. This is negative 1. How about 360 divided by 3? What is the sine of 120? Sine of 120 is the square root of 3 over 2. Or that is times 2. That will be plus the square root of 3 of I. This is the second root. Okay, so again, so cosine of 360 over cosine of 360 divided by 3. This is a negative 1/2. Well, this one is square root of 3 divided by 2. And cube root of 8, this is positive 2. Now, for the third root, this is if we have the value of k is equal to 2. This is for the third root. Is equal to 8 raised to 1 over 3. And multiplied by, we have cosine of 0 plus 360 degrees multiplied by 2 divided by 3 plus we have I sine multiplied by sine of 0 plus 360 degrees multiplied by 2. This is divided by 3. Okay, so we have, let us determine these values. That is cosine of What is the cosine of 360 multiplied by 2 over 3? That is the same as negative 1 half. This is negative 1 half. Well, this one, that is the sine of 720 divided by 2. So we have negative, this is negative square root of 3 over 2. And the cube root of 8 is 2. 2 times negative 1 half is negative 1 plus 2 times the square root of negative 3 over 2 is negative, so which means we are to minus. This is minus the square root of 3 of I. This is the third root. So these are the roots of the roots of 8. We have positive 2, negative 1 square root of 3 plus negative 1 plus the square root of 3 times I, negative 1 minus the square root of 3 of I. So these are the roots of positive 8. Okay, so let's have the square root of 1 plus I, or it's the same as 1 plus I raised to 1 half. So let's have this first converted to the polar form. We have z is equal to 1 plus I. So this is in the first quadrant. If we are to plot this one, we have the value of b is equal to 1, the value of a is also equal to 1, and the argument is theta. We have the tangent of theta is equal to 1 over 1, and the value of theta is equal to 45 degrees. That will be the argument. Then for the modulus, we have r is equal to the square root of a squared plus b squared. We have r is equal to the square root of, this is 1 squared plus 1 squared. Modulus is equal to the square root of 2. So if you have to convert this one to polar form, we have the value of z is equal to r multiplied by cosine of theta plus I. This is the sine of theta. We have z equal to r. That is the square root of 2 multiplied by cosine of 45 degrees plus I. This is sine of 45 degrees. What is the polar form? Now if you are to determine the square root, so we have 1 plus I raised to 1 half is equal to R raised to 1 over n. This is multiplied by the quantity. We have cosine of theta plus 360 degrees multiplied by k. This is divided by n plus I multiplied by sine of the argument plus 360 degrees multiplied by k. This is divided by n. So we are looking for the square root, so the value of n is equal to 2. We are looking for 2 roots. So we are using k is equal to 0 and k is equal to 1. To have two, for example, we have 2 cycles to determine the roots. So for the first root, we are using k is equal to 0, that is r, that is our argument. What is the modulus? That is the square root of 2. This is now raised to 1 half. Multiplied by the cosine. The argument is 45 degrees plus 360 degrees multiplied by 0. This is divided by 2 plus I. This is I sine. Multiplied by sine of 45 degrees plus 360 degrees multiplied by 0, this is divided by 2. So this will be our first root. All we have to do is distribute the square root of square root of 2 raised to 1 half in each term. So if you have to compute for that value or for those values, what is the equivalent of a square root of 2? This is the square root of 2 raised to 1 half. Multiplied by the cosine of 45 over 45 degrees over 360 degrees times 0. So that will be the same as 1.09. Let's have it with 5 decimal places. 1.098 68, then plus I, or what will be the equivalent of square root of 2 raised to 1 half multiplied by, we have the square root of 2, this is raised to 0.5 multiplied by the sine of 45 degrees over 2. So this is 0. Plus speed, we have 0.45509 up I. So this will be the first root. So that is at k is equal to 0. So for the second root, this is, we have the square root of 2 raised to 1 half. I multiplied by, we have the cosine of 45 degrees plus 360 degrees multiplied by 1. This is divided by 2. Plus I, we have the sine of 45 degrees plus 360 degrees multiplied by 1. This is divided by 2. Alright, then we have, let us compute for this value. So what is the square root of 2 raised to 1 half multiplied by this value? We are just to distribute. So we have the square root of 2 raised to 1 half multiplied by the cosine of 45 degrees plus 360 divided by 2. So we have that as a negative, just the negative of this value, I think, a negative 1.09868. Alright, so negative 1.09868. Then on the other, on this term, so we have it also as negative, and this is a negative 0.45509 up I. So we are these are the roots of 1 plus I. So again, since we are square root, we have only 2 roots.